So the residue theorem is giving us 2 pi r, the sum of the given residue. So you are to add residue A plus residue B depending on the number of residue you have in a closed segment. So that is the formula. Then we have an example to evaluate that under the curve z equals to 10. So z is 10. So when we solve our problem, we have z to be 1 and z to be minus 3. You see that when you take the modulus of this 1 square plus 3 square, you still arrive at the square root at 10. So this simply means that 1 and 3 are inside the modulus of 10. So in considering the type of poles they are, we solve using the necessary formula. Then we arrive at for the simple pole, when z equals to 1, we have our answer to be e over 16. Then for double pole as well, when we solve, we have our final answer to be that. So we have our final answer to be pi e open bracket e minus 5 e raised to power minus 3 over 8. So you notice that after everything, after looking for our residues, we add our residues together plus 2 pi I. So take note of that. Then we have if z equals to 3 over 2, this simply means that 3 over 2 is less than, is not among, is not up to 3. So it is only within the cycle of residue of the first residue, which is e over 16, that is z equals to 1. So it is not above 1. 3 over 2 is not above 1. So we only add the first residue in this case, that is plus e over 16. So if z equals to 3 over 2, 3 over 2 is not greater than 1. So in this case, what we do is we only multiply the first residue because we have it to be z equals to 1. So that is why we have our final answer to be pi I e over 8. So let's check some other important example. So we have our integral from 0 to 2 pi. So we make a substitution of z equals to e raised to power I theta, z inverse to be a minus theta. So when we subtract z from z inverse, we have the value for sine theta. Then we substitute it down in sine theta. Then we multiply through by 2. So we have 2 dz. And of course, we already know that dz equals to iz d theta. So on substituting everything, we have our final answer to be pi over 2. So you can just check through the working. Is explicit enough. Mind you, we have the z. When we say the z is ie raised to power I theta, and e raised to power I theta is already given as z. So that is why we have the z equals to I d theta.